Welcome to Study Loop.
All right. So when we're talking about magnetic field strength for absorptions for proton nuclei, this is the equation we're looking at, right? The frequency, um, which corresponds to the energy difference of the splitting in a magnetic field, right? Um, is given by this equation, right? So the frequency of absorption, which corresponds to knocking something from being in the lower spin state to the higher spin state, is given by 2 mu z over h times b, where b is the magnetic field, mu z is the magneto-gyric ratio, and h is Planck's constant. Now, if you plug in all of these values, what you end up with is the following. You get that F is equal to, for a proton, 42.58 megahertz. Right, per Tesla. Okay. And then times B, right? Um, yeah, so this is basically it. So we've been given a wavelength of 1.0 millimeters, right? And so what we can do is, if we can convert this into a frequency, right, then we could solve the equation above for B, right? We could say that B equals F divided by 42.58 megahertz over T, right? Yeah, that's basically it. Okay, so all we need to do is convert 1 millimeter into frequency. Okay, well, remember there's a relationship between wavelength and frequency, right? Wavelength times frequency is equal to the speed of light, c, right? So if we want to know f, we just have to say c divided by the wavelength, where c is the speed of light. Now, currently we have the wavelength in millimeters, whereas the speed of light is typically given in meters per second, right? So we should probably convert this wavelength into meters. Okay, so 1 millimeter is equal to 1 times 10 to the negative third meters, right? That's a thousandth of a meter. Right, so effectively we should get the F is equal to 2.998 times 10 to the 8 meters per second divided by, and then we'll take our 1.0 millimeters, right? But instead of millimeters, we'll say times 10 to the negative third meters, okay? And therefore, we should get, after this 3 cancels with the 8 there, we should get 2.998 times 10 to the 5th hertz, really, right? Because meters will cancel, and we'll just get seconds inverse. Okay. Seconds inverse is the same as hertz. All right, so now we've got F in hertz, but we'll notice that the constant we have here is given in megahertz. Perhaps we want to convert, I don't know, our hertz to megahertz. Okay, well, 1 megahertz is equal to 1 times 10 to the 6th hertz, right? So ultimately, what we're going to get is 0.2998 megahertz. Okay, now we're pretty much ready to just plug this all in, right? We get B, the magnetic field, is equal to 0.2998 megahertz divided by 45.58 megahertz per Tesla. Megahertz are going to cancel. Let's do the math here. We get 0.2998 divided by 45.58 And we're going to get, right, and Teslas will move to the top. We will get 0.00657 Teslas.